Exercise 1.3, we have to do types of functions. For doing 1.3, we need to learn types of functions. First is 1-1 function. 1-1 function. 1-1 function, or you can say injective. Function is what? Injective function. 1-1 function or injective. What do you mean by 1-1 function? A function which is defined from x to y. A function which is defined from x to y is called 1-1 if different elements of x have different images in y. I will explain you with example. If this is x, this is y. This is A, B, C, 1, 2, 3. This different elements A, B, C, 3 distinct elements are given in set X, which are related to set Y. So A is related to 2, B is related to 1, C is related to 3. If x1 is equal to x2, then only f of x1 is equal to f of x2. If x1 is not equal to x2, means f of x1 is not equal to f of x. You can see here, f of a is equal to what? 2. F of a is equal to what? 2. F of b is equal to what? 1. F of c is equal to what? 3. So for different values in x, their images are different. Only in one case, when a will be equal to a, then only their images will be same. So I can say a function f defined by f from x to y is called 1-1, or you can say injective if different elements of x have different images in y. Got my point? It can't be like this, like I will give you x, y, a, b, c, 1, 2, 3. Like a is related to 1, b is also related to 1. Here it is not 1 to 1 because 2. F of a is equal to also 1 and f of b is also equal to 1. Their images are same and elements are what? A is not equal to b, but f of a is equal to f of b. Got my point? X is not equal to y, but f of x is equal to f of y. So it is not 1 to 1. It is many to 1. 2, a and b both are related to 1. Both have their images 1. So I can't say that this function is 1-1 or injective. It is clear? Now, 1-1 function is clear. Now many-one function. Now you can see many-one function. Second is many-one function. Many-one function. Many-one function if 2 or more elements in x, if function is defined from x to y. Now you can see here, this is x, this is y. If 2 or more elements like a, b, c, here 1, 2, 3. This is related to this. B is also related to 1. C is also related to 1. So f of a is also equal to 1. F of b is also equal to 1. F of c is also equal to what? 1. Here what is codomain? Codomain is what? Y. Full set y is called codomain. And range will be what? Only 1. Range will be what? Only 1. And codomain will be what? 1, 2, Is it clear? Or other can be like this also. A, B, C, 1, 2, 3. A is related to 1, C is related to 1, B is related to 3. Only 2 is not related to any element in X. So 1 and 3 will be range here, and full set 1, 2, 3 is called codomain. So this is called many-one function. Now on to function. First we learned 1-1 function, then many-one function. Now this is called on to function. 1-1 function is also called injective function. Now we will learn onto function. Third is onto function. Onto function, or you can say surjective. What do you mean by onto function? If a function is defined f from x to y, if a function is defined by f which is from x to y, if each element of y, I will write here, if each element of y is the image of at least one element of x, that is, what do you mean by if each element of y means, I will tell you, this is x, this is y, this is a, b, c, 1, 2, 3. It is related to this is related to this one is related to this. So here 3 is not related to any elements in x. So this is not onto function, because here codomain is not equal to range. What is codomain? 1, 2, 3, 4 set is not equal to range means 1, so each and every element of y should be the image of at least one element of x. That is, if codomain is equal to range. This is the condition. Codomain of function is equal to range of function. Is it clear? That is, y is equal to f of x. Not a single element should be left behind. Is it clear? This is called onto function, or function is surject. Now, into function. What do you mean by into function? Tell you. What is into function? If a function is defined from a to b, is called into function if there exists at least one element. What is the condition? At least one element in y which is not the image of any element of x. That is, if the range of a function is not equal to codomain of a function, and range of a function is a proper subset of codomain. Got my point? Range of a function is a proper subset of codomain. I will explain here. Into function, if function is defined by f which is from a to b, if there exists at least one element in y, at least, it can be more also, but at least one element in y should be there which is not the image of any element of x, means range will not be equal to codomain. And range of a function is a proper subset of codomain. What do you mean by proper subset? First I will explain this. This is x, this is y. A, B, C, 1, 2, 3. This is related to this. This can be related to this. This can be related to this. D also related to this. Related to this. So here codomain is equal to what? Y full set, that is what? 1, 2, 3, 4. And range is equal to only 1, 2, 4. Only elements are 1 and 2 and 4 are the image of any element of x. So at least one element should be left behind to make it into function. If it is like this, A, B, C, 1, 2, 3, all are related to what? 1 only. So 2, 3 are left. So it is what? At least one element. Condition is satisfying. At least one element. Here 2 elements are left which are not associated with any element of X. So we can say this is also into function. Because here range what? 1, 2, 4 codomain is equal to what? 1, 2, 3, 4. What is a proper subset? If this range is a proper subset of codomain, so range is what? 1, 2, 4. So all elements of range are present in codomain, but at least one element should be there in codomain which is not present in the range. That's why we say that the range of F is a proper subset of codomain. In proper subset 1, 2, 3, 4 codomain can't be a proper subset of codomain. So range, at least one element is different in this, and here 1, 2, 4, here 1, 2, 3, 4. So at least this element is different. 3 is different here. So I can say range is a proper subset of codomain. Is it clear? Like this you have to do. Now 1, correspondence. 4 functions we learned. 1, function, that is called injective function also. Then many one function. Then onto function, that is called surjective also. 4th was into function. Now 5th we are learning 1, correspondence. 1, correspondence. Or you can say the function is bijective. What do you mean by bijective? If the function is 1, also and onto also, then we will say that the function is bijective. 5th we will learn 1, correspondence. 1, correspondence. A function which is from X to Y is called a 1, correspondence, or you can say bijective. Bijective means it is surjective also and it is injective also. Injective means 1, function also, surjective means onto function also. If a function is both 1, and onto, then I can say the function is 1, correspondence or bijective function if both are, if a function is both 1, and onto. I will explain you. Same A, B, C, 1, 2, 3. For a function to be 1, all elements are related to different. Onto means what? Not a single element is here, not a single element is there which is not associated with any element of X. All elements are related to any element of X. So here codomain of F is equal to range of F. Here range is what? 1, 2, 3. Codomain is also what? 1, 2, 3. So I can say it is onto 1, Fa is equal to 1, Fb is equal to 2, Fc is equal to 3. A is not equal to B is not equal to C, so F of A is not equal to F of B is not equal to F of C. If X is equal to Y, then only F of X is equal to F of Y. Here you know F of A is equal to what? 1, F of B is equal to what? 2, F of C is equal to what? 3. So A is not equal to B, so F of A is not equal to F of B. F of B is equal to what? 2, F of C is equal to 3. So B is not equal to C, that's why F of B is not equal to F of C, like this. If A is equal to B, then only F of A is equal to F of B. Is it clear? So this is 1, correspondence, or you can say the function is bijective. Now one more thing we learn. These were important types of functions. Now we have to learn general entity, identity function. Identity function. What do you mean by identity function? If a function is defined from real number to real number, domain is also a real number and codomain is also a real number. This is what? A real number. Here this is also what? A real number. So you can say one real number to real number. So if it is A, B, C, here also it is what? A, B, C, it is real number set. Here also it is real number set. So A is related to A, B is related to B, C is related to C. So here what? Domain is equal to what? Range. Domain of a function is equal to range of a function. So it is called identity function. If f of x is equal to what? X, y is equal to what? X. F of x is equal to x. Identity function. A is related to A itself, B is related to B itself, C is related to C itself. So f of x is equal to what? X means what here? F of A is equal to what? A. F of x is equal to x. F of x means what? Y. Y is equal to what? X. Or this is equal to this. So A is equal to A. So domain x belongs to, here I am saying f of x is equal to x. So y is equal to x. So domain x belongs to R and range y also belongs to R. Is it clear? So identity function, if defined from real number to real number, so I am writing like A, B, C is real numbers. Here also A, B, C is real numbers. All are same. Here domain is equal to range. So I can write f of x is equal to what? X, because elements are same. So y is equal to what? X. It means f of A is equal to A, f of B is equal to B, and f of C is equal to C. So domain here x belongs to, x means what? A belongs to this domain, B belongs to this domain, C belongs to this domain, and these A, B, C belongs to this codomain, that is R. Is it clear? So if I plot graph of an identity function, now I will explain here. You know f of x is equal to x, or you can say y is equal to what? X. This is identity function. So you know graph of an identity function, graph of an identity function is always a straight line, is always a straight line which passes through the origin, which passes through the origin. I will explain you how. Let's say fx is equal to x. Let's take some values. X, y. If I am putting x 0, so fx is equal to x. So y is equal to what? X. If x is 0, y will be what? 0. If x is 1, y will be what? 1. If x is 2, y is what? 2. If x is 3, y is 3. So if I draw a graph, 0, 0 means this point. 1, 1, let's say this is 1, here it is 1, so this point is 1, 1. 2, here it is 2, here 1, 2, 3, 4, here it is 1, 2, 3, 4, so 2, so this is 2 point, this is 3 point, this is 4 point. Like this it will be a graph. And you know it is defined for real numbers to real numbers. So it can be negative also. If x is minus 1, y is also minus 1. It is minus 2, it is minus 2, it is minus 3, it is minus 3. So here it is what? Minus 1, here it is what? Minus 1. So this point, minus 2, minus 2, so this point. Like this you have to consider. So always graph of an identity function is always a straight line which passes through the origin. Is it clear? Now identity function is over. Now you have to learn constant function. What do you mean by a constant function? You have to learn constant function. Here also function is defined from real number to real number only, real valued function only. So we are learning that constant function. F is from R to R. So for any real value, from domain, for any real value from domain, there is only one image. There is only one image. Like I will explain. For any real value from domain, there is only one image. If it is like this is a real value, this is one value. 1, 2, 3, 4. Here A, B, C, D. 1 is related to A, 2 is also related to A. Or you can write ulta also. It will be easy. 1, 2, 3, 4. Here is 5, 6. So real number to real number. For any real value from domain, there is only one image in codomain. So 1 is related to 5, 2 is also related to 5, 3 is also related to 5, 4 is also related to 5. So f of 1. Here different real values 1, 2, 3, 4 from domain. There is only one image in codomain, that is what? 5. So f of 1 is also 5, f of 2 is also 5, f of 3 is also 5, f of 4 is equal to 5. So all functions value, if you will put x from codomain, any real value from codomain, there is only one image in codomain. So I can say this is a constant function, 5, 5, 5, 5. This is a constant function. Or I can say f of x is equal to c, that is what? Constant. F of x is equal to c, constant, where domain x belongs to real numbers from this and domain x belongs to R, and range is equal to what? C. Range is equal to what? C. I will explain with example. If I will draw a graph, so here it is what? Range is equal to C. It means if I write fx is equal to 5, any constant number, fx is equal to 5, it means what? Y is equal to 5. If I write fx is equal to 3, it means what? Y is equal to 3. If I write fx is equal to what? Minus 3, that is what? Fx is y is equal to minus 3. So if I draw a graph, y is equal to 3, y is equal to 5, y is equal to minus 3. So let's say this is 1, this is 2, this is 3. This is 1, minus 2, minus 3. Here it is 4, here it is 5. Y is equal to 5. This line, horizontal line will be there. Y is equal to 3, so this line will be there. And y is equal to what? Minus 3. So this line will be there. So always graph of a constant function. Graph of a constant function is always a horizontal line, or is always a straight line which is parallel to x-axis, which is always parallel to. So graph of a constant function is always a straight line which is parallel to x-axis. It is clear? So this was what? Constant function. Now identity function we learned, constant function we learned for real valued functions. Now we have to learn equal functions. To learn equal functions. Equal functions. If two functions are given, f and g, two functions f and g are called equal. When the two functions will be equal, conditions and then are called equal if domain of f, means these are necessary conditions. Domain of f is equal to domain of g. Domain of f function is equal to domain of g function. And second, f of x is equal to g of x for all x in domain of f or g, because domain is same. First condition is what? Domain of f is equal to domain of g. If you put f of x, it should be equal to g of x. Only in that case two functions will be what? Equal functions. So if domain of f is equal to domain of g, and fx is equal to gx for all x in domain of f or domain of g, because both domains are same. So if I'll say one example, I'll take, let a is equal to 0, 2, b is equal to 1, 2, 3, 4, 5. Function is from a to b, f is from a to b, and fx is equal to 2x plus 1. And here g's function is defined from a to b only, because domain is same, codomain is also same. So first condition is what? Domain of f is equal to domain of g, and fx is equal to gx. This b is same, so range will also be same. So g is from a to b. It is given gx is equal to x square plus 1 for all x belongs to a. Here also for all x belongs to a. So here domain of f is equal to what? A, and domain of g is equal to what? A. So both domains are same, so condition is satisfied. Now fx is equal to gx or not, we have to check. So first I will substitute x values I have to take from domain. So f of 0 I will calculate, and f of 2 I will calculate. G of 0 I will calculate, z of 2 I will calculate. And if I prove that f of 0 is equal to z of 0, means f of x is equal to z of x. So it will be a equal function. F of 2 is equal to g of 2, f of x is equal to gx of 2. So I have to equate values. F of 0 will be what? 2 into 0 plus 1. 0 and 2 I have taken from this domain. 2 into 0 plus 1, that is what? 1. 2 into 2 plus 1 is what? 5. So 1 and 5. Values are what? 1 and 5. Here z of 0 is what? 0 square plus 1 means what? 1. Z of 2 is what? 2 square plus 1, that is what? 5. So you can see f of 0 is equal to z of 0. F of 0 is equal to z of 0. And f of 2 is equal to g of 2. It means f of x is equal to g of x for all x in domain of f or g. So both conditions are satisfying. That's why we can say that both functions are equal functions. Is it clear? Now zero function. Zero function. You will learn zero function. I will define for integers z. Let z be the set of all integers. Let z be the set of all integers. Then the function is defined, zero function is defined. Let the function f naught is from z to z defined by f naught zero function value x is equal to 0. If you put any value of x, you will get function what? Any value if you put from domain, you will get what? 0. For all x belongs to z, that is what? Domain, this one is called the zero function. Zero function of on z. It is what? Zero function on integers. So zero function on integers. First is what? Zero function on integers. Let z be the set of all integers, then the function f naught. This is represented by zero function is represented by f0. It's from z to z. Here it is what? Domain. This is codomain defined by f naught x. If you put any value from this integer domain, you will get value what? 0. Then you will say this is a zero function on z. Same you can do zero function on set of real numbers. Zero function on set of real numbers. Second part we'll learn in this. Second, zero function on real numbers. So let R be the real numbers. Let R be the real numbers. Then the function f0, f0 is from R to R, defined by f0, same x is equal to what? 0. If we put any element from this domain, you will get value 0 on that function. So for all x belongs to R, this R is which one? This domain. For all x belongs to R, x belongs to the domain, value you are getting 0 is called the zero function on R. Is called the zero function on R. Zero function on R. So we learned two zero functions on Z and zero functions on R. Zero functions on integer and zero function on real numbers. Or sometimes the zero function is defined by 0 also. Is it clear? Sometimes the zero function is defined by 0 also. Otherwise we write f. Now, last part, monotonic functions. We have to learn monotonic functions. We will explain what is a monotonic function. Four type of monotonic functions we will learn in this. Increasing function, strictly increasing function. First I am telling increasing function, strictly increasing function. Strictly increasing function. What do you mean by increasing function and strictly increasing function? Let function f be a real valued function. These all we are learning for a real valued function. Real valued function means what? Domain and codomain is real number. Let f be a real valued function. Then function is called increasing function only when if x1 is less than x2, then f of x1 is less than equal to f of x2. If x1 is less than x2, then f of x1 is less than equal. It can come equal also. x1 is less than x2, then fx1 is less than equal to f of x2. If as we move from left to right, the function value do not decrease. Left to right you are going x1, x2, x3. Increasing function. So f of x1, f of x2. F of x2 is more than f of x1. But it can be equal also. In this case you can say it is an increasing function. What is the difference between increasing function and strictly increasing function? Here you see if x1 is less than x2, so f of x1 can be less than equal to fx2. Means less than fx2 but can be equal to fx2 also. But in strictly increasing function, if x1 is less than x2, f of x1 is always less than f of x2. It can't be equal. So it is called strictly increasing function. And here values x1 and x2 belongs to the domain of function. Here I will write x1 comma x2 belongs to domain of a function. Now it is clear. Increasing function, strictly increasing function. Same you have to do for decreasing function and strictly decreasing function. These all we are learning in the monotonic functions. Strictly decreasing function and decreasing function. And decreasing function. What do you mean by decreasing function? Decreasing function means if x1 is greater than x2, I will write like this. If x1 is greater than 1 minute, or you can write like this. Decreasing function, how will I be defined? If x1 is less than x2, decreasing function I am telling. If x1 is less than x2, then f of x1 is not less than equal to f of x2. It is greater than equal to f of x2. Reverse of increasing function. Increasing function, what we learned? If x1 is less than x2, f of x1 is less than equal to f of x2. But it is what? Decreasing function. So if x1 is less than x2, if x1 is less than x2, then f of x1 is greater than equal to f of x2, where x1 comma x2 belongs to the domain of a function. Is it clear? Now, strictly decreasing function will be what? Strictly decreasing function. If x1 is less than x2, if x1 is less than x2, then f of x1 is always greater than f of x2. It can't be equal to f of x2. If x1 is less than x2, then f of x1 is always greater than f of x2, and here also x1 comma x2 belongs to domain of a function. This is called a strictly decreasing function. If x1 is less than x2, f of x1 is always greater than f of x2. And decreasing function, if x1 is less than x2, then fx1 can be greater than equal also to f of x2. This is called monotonic function. This we are learning in monotonic function. 4 functions we learned in this monotonic functions. First is what? Increasing function, strictly increasing function, decreasing function, and strictly decreasing function. So now a function which is either increasing or decreasing is called monotonic function. Now what is monotonic function? First we learned 4 things: strictly increasing, strictly decreasing, decreasing, increasing. So if a function is either increasing or decreasing, either increasing or decreasing, is called monotonic function. Is called a monotonic function. Simple, you will say that is a monotonic function. Whether a function is increasing or decreasing, simple increasing function or decreasing function, you will say that is a monotonic function. And if a function is either strictly increasing or strictly decreasing. Here word is what? Strictly increasing or strictly decreasing, then it is called, if a function is either strictly increasing or strictly decreasing, is called a strict monotonic function. Strict monotonic function. Strict monotonic function. Strict monotonic function. I will give you one example. F of x is equal to what? 3x minus 1. F of x is equal to 3x minus 1 is what? Strictly increasing or increasing? Strictly increasing or increasing? First we will put values. Let's put x is equal to 1. You will get f of x what? 3 into 1 minus 1, that is what? 2. If we will put f of, here it is 1, f of 2, so it will be what? 3 into 2 minus 1, that is what? 5. If we will put f of 3, you will get what? 3 into 3 minus 1 is equal to what? 8. So if x1 is less than x2, means 1 is less than 2, then f of x1 is also less than f of x2. Here you can see it is not equal, but f of x1 is less than f. If x1 is less than x2, then fx1 is less than fx2. Then you can say this is what? Strictly increasing function. You can see here f of 1 is what? 2. F of 2 is what? 5. So 2 is less than 5. If 1 is less than 2, then 2 is less than 5. This condition is satisfying. That's why I can say this function f of x is equal to 3x minus 1 is a strictly increasing function. Is strictly increasing function. Now one more example I will give for strictly decreasing. You can say fx is equal to one function I'm writing fx is equal to 1 minus 3x. If you will put x is equal to 1, you will get f of 1 what? 1 minus 3 into 1, that is 1 minus 3, that is minus 2. If I will put x is equal to 2, f of 2 will be what? 1 minus 3 into 2, that is 1 minus 6, so minus 5. Is it clear? 1, 2, minus 2, minus 5. 1 is 1 minus 3x. So if you are putting 1, you are getting 1 minus 3 into 1. X is equal to 2, so 1 minus 3 into 2, that is minus 5. So you know here x is equal to 3, if I put, you will get f of 3 is equal to what? 1 minus 3 into 3, that is 1 minus 9, that is minus 8. X is equal to 1, f1 is equal to minus 2. X is equal to 2, f of 2 is equal to minus 5. So you see x, here x1, give x1, x2, x3. This is x1, this is x2. So x1 is less than x2, you can see 1 is less than 2. But f of 1 is what? Greater than f of 2. But what you need? For strictly increasing function, if 1 is less than 2, then f of 1 is also less than f of 2. But here you can see minus 2 is greater than minus 5. That's why it is not strictly increasing function. It is strictly decreasing function. This we have to learn. Is it clear? And one more. What is a strict monotonic function? If a function is either strictly increasing or either strictly decreasing, it's called a strict monotonic function. And a strict monotonic function is always 1-1 function. Always 1-1 function. A strict monotonic function is always a 1-1 function. Okay. Now, only last concept we have to learn, that is even and odd functions. Even and odd functions. Last concept is even and odd functions. Odd functions. What do you mean by even and odd function? A real function f. A real function f. What do you mean by real function? All we are learning under real function. Means domain and codomain are real numbers. A real function f is called an even function if f of minus x is equal to f of x. It's called an even function if f of minus x is equal to f of x for all x belongs to domain of a function. And f is called an odd function. And a real function f is called an odd function if f of minus x is equal to minus of fx for all x belongs to domain of a function. Then you can say this function is what? Odd function. Even function is what? If you put at the place of x f of minus x, at the place of x if you are putting minus x, the equation does not change or the function does not change. The function is same as it is as f of x. Then I can say this function is an even function. A function is called an odd function when I will put minus x. The whole function you have to minus with 1. Minus 1 you have to multiply. So all sign will change. So this is called odd function for all x belongs to domain of a function. These all basics we will use in exercise 1.3 in next video. Thank you.